In this video, we'll look at some notation questions. And so the first one is, when you have two graphs times together or even divided, if they're bigger than naught, it means we're looking for where they're in the same place. In other words, where they're both above or both below the x-axis. Because if this graph was positive and this was in the same place, so it was positive, positive and a positive makes a positive which is bigger than naught. If fx was below the line, so if it was negative and at the same time g was negative, a negative times a positive, a negative times a negative would also make a positive. And so when I see this inequality sign bigger than, I immediately just write the English word same. It's just in the same place. And so if I look at this question here, in the beginning, the G graph, the green one, is above and the red one is below. So they're in different places to the ground level, which is your x-axis. Okay, what happens after -1? I would say both graphs are above, so they're in the same place. So from -1, they're in the same place. They're in the same place. They're still in the same place in that they're both above this line. They're in the same place. What happens at 3? They now end up both below, so they're still in the same place. So maybe to be safe, I'm just going to say it's from there till 3. And then again, it happens when x is bigger than 3. You could combine this answer just to write it as x is bigger than -1, but you'd have to think a bit harder and not let it include 3 because they didn't want it to include 3. Ditto, if you're doing an answer where it's greater than or equal to, even the fact that it's divided, you're going to do the same thing except that the LCD graph can never equal 0. And so the G graph can never equal 0. So at 3, I must make sure I don't put a or equal to sign. So the answer to this one would look the same because it was where they were in the same place. So it should be or equal to, but I'm not going to put it wherever the G graph equaled 0 because then it would be undefined. So my answer to the second question would look like that. Whereas, completely differently, when I notice that I'm timesing graphs together or dividing graphs and it's less than 0, then that just means I'm looking where they're in different places. If this is my exam, the minute that I see this, I wouldn't be subbing in my graphs like some of you may be tempted to do. I would literally just say different, where they're in different places. So in the beginning on the left, the green graph, the straight line was above this line, and the red was below. They're in different places until -1, because then they end up in the same place. So where they're in different places, when x is less than -1, then they're in the same, then they're in the same. I'm not interested in it equaling 3. Neither of these questions ask for it to equal 3. And what happens after 3? They're in the same place. They're both below, but I want it different. So this would just be my answer. So when I get these questions, it really helps to just think, is it in the same place or is it in different places? And I look at my picture from there. I'm not saying different as in this guy's above and this guy's below. It's just looking at the x-axis as ground level and saying, are they both above, both below, or in different places? I hope that you found this video, which is sometimes a confusing concept, made things a lot easier and better for you. If it did, please like this video, subscribe to our channel, and share this with your friends.